Okay, in this video, we're going to review solving equations, which is the third page in your Unit 1 notes booklet. So in the last video, in the last lesson, we talked about algebraic expressions. An algebraic expression is something without an equal sign, so 9x plus 3 in an expression. An equation always has an equal sign, and it always has a left side and a right side. You can think about that equal sign in math as just meaning is the same as, or even just is. So this means that 9x plus 3 is the same as 21, and we need to find what value of x makes that true. So our goal when we're solving an equation is always to get the variable, so that's the letter, by itself on one of the two sides. Could be the left side or the right side, but when I'm done this question, I want to make sure that I have x all by itself. So I need to get rid of the plus 3 and the times 9. So the first thing I'm going to do is subtract 3 from the left side. So if I want to get rid of something in math, I need to do the opposite. So plus 3 minus 3 would be 0. But if I do something to one side, I have to do the same thing to the other side. So I'll do minus 3 on the other side. So now I'm left with just 9x on the left side, and I'm left with 21 minus 3 equals 18 on the right side. So when I have 9x, that really means 9 multiplied by x equals 18. So to get rid of the 9, I have to do the opposite operation. The opposite of multiply is divide. So I'm going to divide the left side by 9. And if I do anything to one side, I have to do the same to the other side. So I'm going to divide 18 by 9 as well. So 9x divided by 9, well, 9 divided by 9 just cancels out. That's 1. So I've got 1x. And then 18 divided by 9 is 2. So we're going to keep doing opposite operations until my variable is by itself. So x equals 2. One other thing I'm going to talk about is that we can always check our answers with what's called a left side, right side check. So I want to know, am I right? Is x equals 2? The great thing about algebra is we can always know if we're right before moving on. So if I look at my original equation, my left side was 9x plus 3, and my right side was 21. So I think x was 2, so I'm going to substitute 2 in every time I see an x. So in this equation, it's just on the left side. So I've got 9 times 2 plus 3. If I use my order of operations, I got to do multiplication first. So 9 times 2 is 18. 18 plus 3, sure enough, is 21. Because the left side equals the right side, I know that I solved this equation correctly. If I had any other number other than 2, my left side wouldn't equal my right side. So when we're solving equations, if we do a left side, right side check, if I get the same number on both sides, then I know I'm correct. If I don't have the same number, I've either made a mistake in my algebra or a mistake in my check. So we'll do a few more examples. In example 2, you notice x is on the right side. So again, my goal is to get x by itself. So again, I'm going to move the negative 3 onto the other side. I could do plus 3 and plus 3 on both sides. Another way to think about solving equations is if something is moving across an equal sign, the sign just flips. So if I want to move the negative 3 onto the left side, then it's going to become a plus 3. So I'm going to have 5 plus 3 now equals x divided by 2. 5 plus 3 is 8. So x divided by 2 equals 8. Remember that a fraction just means division. So x over 2 is the same as x divided by 2. And again, to move the divided by 2 on the other side, I need to do the opposite. So I'm going to have 8 times 2 equals x. So x has to equal 16. And then again, if we wanted, we could do a left side, right side check. Even if you don't formally write it down, it's a good idea to do this in your head. The left side of my original equation was equal to 5. The right side equals x over 2 minus 3. And I've got this line in the middle to physically separate the two sides, because what I want to see is, am I right? Is it true that my equation is balanced, that the two sides are the same? So I'm going to substitute in 16. This is what I think x is. And again, follow BEDMAS. So 16 divided by 2 is 8. And sure enough, 8 minus 3 is 5. My left side is my right side. Therefore, I must have been correct. So again, if I'm solving for x, I need to get rid of everything else on the same side. And when things move across the equal sign, I'm just doing the opposite operation. So negative becomes positive, or multiplication becomes division, etc. We're just going to do a couple more examples. I don't know why that says example 5. I guess it should be example 4. This is kind of combining the last two lessons. So my first step is to get rid of all the brackets. So I'm going to use my distributive property. So I'm going to do 3 times 4x. Well, that's just 12x. Then I'm going to do 3 times negative 9 is negative 27. On the right side, I'll do 5 times 2x is 10x. And then I'm going to do 5 times negative 5 is negative 25. So the difference in example 3, other than the brackets, is that I've got x's or variables in multiple places. So I want to move all my x's onto one side and then move all my numbers, which we also call constants, onto the other side. So what I'm going to do is I'm going to move this 10x to the left side. So positive 10x now becomes a negative 10x. And I'm going to move the negative 27 onto the right side. So I've still got negative 25. And when I move the negative 27 over, it becomes a positive 27. Well, now I'll collect term. How many x's do I have? 12 x's, take away 10 x's. Well, I've got 2x. And then negative 25 plus 27, I've got positive 2. So now to get x by itself, well, it's getting multiplied by 2. So to get rid of that times 2, I have to divide the other side by 2. And then 2 divided by 2 is 1. And I'm not going to do it in this video, but I could do another left side, right side check if I wanted to. So if I have x's and numbers in multiple places, our goal is to move all the variables on one side and all the constants on the other, and then we can collect like terms and solve. One last example. We've got a couple fractions. I'm not a big fan of fractions. So what I'm going to do is at the start of this, I'm going to show you a quick step to get rid of all the fractions from our problem. What I'm going to do is I'm going to multiply every term by the lowest common denominator. So you notice I've got denominators of 3 and 4. What do 3 and 4 both divide into? Well, my lowest common denominator is 12, right? 3, 6, 9, 12. And here would be 4, 8, 12. So they both divide into 12. So I'm going to multiply every single one of these terms by 12. So I'm basically doing the same thing to both sides, so I'm not altering the equation. So 2y times 12 is going to be 24y, still over 3. Negative 1 times 12 is negative 12. 5y times 12 is 60y. And 3 times 12 is going to be 36 over 4. So I'm really just multiplying numerator by numerator because my denominator of 12 is just 1. So remember when we're multiplying fractions, it's top times top, bottom times bottom. But when I'm multiplying by a whole number, the bottom is always just 1. You can just think about multiplying each of the tops by 12. And now, because I picked the LCD, the lowest common denominator, this will always reduce to a whole number. So 24y divided by 3 is 8y. So I've got 8y minus 12. And then 36 divided by 4 is 9. So now I've got something that looks more like example 3. I've got whole numbers. So I'm going to bring all my y's to the left. You can pick either side. So positive 60y, when it moves across, it becomes a negative 60y. And on the right side, I still have positive 9. And the negative 12, when it moves over, it becomes a positive 12. So I've got 8 minus 60. So I've got negative 52y's. You're welcome to use a calculator for some of these steps. And then I've got 9 plus 12 is 21. So right now, y is being multiplied by negative 52. So to get rid of that negative 52, I have to divide both sides by negative 52. So now I've got positive y equals negative 21 over 52. And I could try to reduce this fraction, but in this case I can't, right? I can only divide 21 by 3 or by 7. And I can't divide my denominator by either of those numbers. So that would be my final answer at the fraction in lowest terms, which is what we like in this math course. So that's a lightning quick review of solving equations. There is some practice problems, 9 equations for you to solve. In the textbook, I know you don't actually have a physical textbook, but I've posted the PDF on our online learning platform. Okay, again, if you have any questions, please shoot me an email, and thanks for watching.